Alright, welcome back to the channel again. Alright, so we're just picking up with the same reactions of the aldehyde. So we had oxidized our aldehyde that we had produced with potassium permanganate. So these two test tubes were the aldehyde that we have oxidized. So I was just testing it to see if they were converted to carboxylic acid, and the first thing I did was to place a blue litmus paper in it. So I'm going to do it and let you see it as well. So here's the blue litmus paper. Right? And it has changed to red. So we know it's an acid. The same thing I'm going to do again. It has changed to red. So the aldehyde has been oxidized to the carboxylic acid. So I'm going to do a next reaction. I'm going to add sodium carbonate because we know that it should fizz when we add it to ethanoic acid. So we started out with ethanol. We had oxidized it and collected the distillate, which is ethanol, and oxidized the ethanol to ethanoic acid, which we have here. So I'm going to get some sodium carbonate and add it to the container. Alright, so I'm going to pour it a little in a new test tube. Alright. And I'm going to add this sodium carbonate. Alright, so I'm going to add the sodium carbonate now. And as you can see, it fizzed. So I'm going to compare this same reaction with ethanoic acid, which we know, so not the one we have prepared. And I'm going to do it with formaldehyde and compare them. Alright, so here I have 4 containers with pure samples or confirmed samples. This is alcohol, ketone, aldehyde, and carboxylic acid. So this is ethanoic acid. Change it to red. This is the aldehyde. Changes it to red. That is the ketone. It is still blue. And the alcohol is blue. So alcohol and ketone blue. Aldehyde and the carboxylic acid is red. So you can comment and tell me why the aldehyde changes the blue litmus paper to red, but the ketone does not, as well as the alcohol. Right? So carboxylic acid and the aldehyde change it to red. The alcohol and the ketone did not. Alright, next I'm going to add the universal indicator. So it's red in the acid. Hold on just a second. So it's red in the acid. Right? Same thing for the aldehyde. It's orange, slightly orange for the ketone. And now for the alcohol. It's yellow. Alright, a little close to orange, but it's kind of yellow or orange-ish. Now these are the samples of the aldehydes that we prepared and oxidized with the potassium permanganate in the test tube. Alright, so I'm pouring them out. And we're going to do the same thing as we did with these compounds. Okay, so I had paused the video and did not realize that I didn't press it back to start. So remember we had the aldehydes in these 2 test tubes, so I had poured them out in this beaker. right? And again, I add the blue litmus paper, right, to show that it changes it to red. Now we know that both the aldehyde and the carboxylic acid changes it to red. So again, I did not pause it and did not play it back. So I added the universal indicator to the sample of aldehyde that we prepared. Well, it's now carboxylic acid, and that is what we're confirming. So I added this universal indicator, and it is also red. So carboxylic acid and the aldehyde, these are definite aldehyde and carboxylic acid. This is the one we are confirming. Alright, so now I'm going to add the ketone. So this is a sample of the formaldehyde. Alright, right here. So I'm going to add some sodium carbonate and observe how it reacts with it. Alright, so here we go. Nothing. Alright, let me add a little more. Alright, here we go. Alright, so there we have, that's orange and green. So we have the color change. Well, the universal indicator was in there. So the pH of the solution is changing. Hence you have the color change. But in terms of the reaction, not, you have a few bubbles being formed, right? So let's go now with the ethanoic acid and see how it reacts. Alright, so here is our sample of well, not the sample. This is actual ethanoic acid, right? And as you can see, definitely there is a difference. So you can see the difference in reactivity now, right? The carboxylic acid reacts much stronger with the sodium carbonate as expected than the aldehyde. So even though both of them change the blue litmus paper to red, we can see a clear distinction in the reaction between the carboxylic acid and the ethanoic acid as well. So let's go back now to our sample and compare the reaction, the vigorousness of it between our known aldehyde and our known carboxylic acid, and see which one it is similar to. Alright, can show that more. Alright, so here we go. And you can see that it reacts vigorously, just like our known carboxylic acid. So we can confirm that this is the aldehyde was oxidized to the carboxylic acid, right? And you can note the color change of the indicator. Remember, it was red and it's now like this. So let's add some more sodium carbonate. Alright, so let's add some more. So you can see it reacting vigorously as well. And I want you to note the color, it is changing right? Look at the differences in the colors. Let's add some more sodium carbonate again. So let's add some more sodium carbonate to our known aldehyde, right? So you can see the different colors. So the green now, if you notice how much sodium carbonate I had to add to the to this sample, right? So if you notice how much I had to add to this sample of acid because it is stronger, right? So you can see that the aldehyde, even though it has acidic properties, it's very weak because it was neutralized quickly, so we get the green color. All right, remember it was red and it changed to green very quickly. But for this one, we added about 3 spatulas, right, of the sodium carbonate before we get the green color. Let me do the same for our known carboxylic acid. Let's go again. This is very concentrated. So as you can see now, it has changed from orange, so we are getting closer to green. So I'm just showing you the, right? So it would have eventually changed to green now, right? When it has all the acid would have been reacted. But clearly we can see that this one is the acid, right? Because it reacted like the acid. So we can confirm that our ethanol was converted to ethanol, the aldehyde, and further oxidized to the carboxylic acid when we added the potassium permanganate, and we proved it, right? So we compared the reactions between a known aldehyde and a known carboxylic acid, right? And this is our sample in the middle. All right, so that's it for this video. All right.